Hello, everyone. In this final project, we're going to talk about the disaster message classification, and here are our group members. As you can see, we've divided our presentation into three parts. The first one is introduction, and which includes the background and the purpose of the project. And we will also give you a brief intro for the dataset we used. And then is code implementation, which consists of three parts. There are data process, model building, and model improvement. And the last part is conclusion. Firstly, I'm going to talk about the background of this project. Disasters can happen anywhere and at any time. The very nature of the disaster is unpredictable and can change in scope and impact. Therefore, we decided to use the dataset that records disaster response message to create a search web app which can help to quickly understand the sentiments of the citizens around the globe during a disaster and how their response are. It also provides a more efficient way to understand citizens and ultimately helps governments develop better policies accordingly.
So the purpose of our project is conducting text analytics and natural language processing to help improve disaster response by classifying input disaster messages into 36 categories of intent and content. And so to achieve this goal, we will build a classification model and create a web app demo where the users can input their message and the model will output its intent. And our project is inspired by the Udacity course on data science. So to talk about our dataset used in this project, the dataset contains 30,000 messages drawn from events, including earthquake, floods, storms, and news articles spanning a large number of years and 100 of different disasters. And this dataset contains the original message in its original language, and the English translation and 36 of classes for message content. Then I'm going to talk about the packages we used in this project. So for natural language processing packages, we've used NumPy, Pandas, SQL, Alchemy, and also NLTK. And as for the modeling part, we used Scikit-learn and Pickle. And for the last part, the web development, we've used Flask.
Hi, so for data pre-processing, we will create some functions and there are 6 different steps to reach the goal. First of all, we will load the initial data set and all classes are combined by a comma into one string. And for the next step, we will split the categories, columns, and set it as a string. And for the third step, we will extract unique category names for the next step. And for fourth step, we will convert the categories into 36 columns with binary values. After cleaning up the dataset, we will save the dataset into our SQL database. For the final step, we will create a function for debugging. That is the whole process for the data pre-processing.
And so for the modeling part, we mainly use the random forest classification model. Since we have multiple class label for each message and they're not mutually exclusive, so we're gonna train 36 random forest model for each of the class. And here is the structure of our pipeline. There's mainly 2 parts. The first part is for during the feature pre-processing, we create a new feature by count the character of each message, and also we convert the text message into word vectors, and then we combine the feature, we feed the feature into our random forest model. So here's the utility function we defined. So the first tokenized function is to convert sentences into word vectors. This function is used in count vectorizer to specify the tokenizer we want to use. And the second function is the count character to count the number of characters in each message, as we mentioned before. This will produce a new feature which will be added to the word vectors. And then we can initialize a random forest classifier pipeline with parameters we defined before. And then we made prediction for each category to evaluate the performance of our model on each class and generated the classification report for each category. The results shows that our model performed very good on some general categories such as food, flood, storm, and weather related, while it did very poor on some rare events like refugee tools, hospital, or fire. The potential reason for this difference is that might be that the categories belongs to rare events that we don't have enough data points to train this model. Finally, we tune the model with two combination of parameters, and estimators and class weights, and we use cross-validation with 5 folds to find out the optimal values for these two parameters. And the results shows that we won't add class weights, and we will use 50 estimators. So here's a web demo for this project. There are 2 main parts. The first is a visualization of the data sets. And the second part is the user can input some messages, and the web is going to call the model and to output the related keywords. Here we can have an idea of this demo. Here's the distribution of message genre and also the frequency of response categories. As we can see for offer tools, hospitals, we have really a few records that also explain why our model perform poor on these kind of categories. And then we can try a simple message. I need some food and water, and click on the classify message. Then we can see the results of request aid related water and food pop up. So here's this is just to get a feeling of this project demo.
And for the last part is conclusion and challenges of this project. In this project, we built a random forest model based on the disaster message. The model aims at accurately classify and input message into the right intent so that disaster response staff can quickly figure out the request and respond accordingly. Since the class labels are not mutually exclusive, meaning one message can fall into multiple intent classes. This is multi-label classification problem, which is the most challenging part in this project. In this case, we decided to try a random forest model for each class label and combine the results. Since random forest is more robust than decision tree and is fast to train. That's all. And here is the reference. Thank you for watching.